In this video, we'll compare EXPONDIST and Weibull in both the probability density function and cumulative distribution function over the values of x from 1 to 6, and our beta is from 0.4 to 2.5. We begin with the value of beta. Data validation, list of items, that is from 0.4 to 0.5. We can start at 0.4. Now we complete the EXPONDIST and the Weibull functions. So starting with the probability density functions, our formula of the EXPONDIST of the x values, where our beta is 1 over beta. That's our lambda, 1 over beta, and 0 because this is probability density function or decay function. Likewise, the Weibull function. Our formula, Weibull of the x values, our lambda, our alpha is 1 because we're comparing EXPONDIST, and the beta is this up, and 0 because this is the probability density function. You'll notice these values are exactly the same, but just increase this. They're way big, yeah. Now the cumulative distribution function, our formula, EXPONDIST of the x values from where alpha 1 over beta, that's our lambda, 1 over beta, comma 1. Likewise, the Weibull function is equal to array formula, Weibull of the x values, comma, our alpha is 1, and this is our beta, and 1 because this is the cumulative distribution function. And we also enter the Taylor series, the polynomial regression. But before we do that, we use the chart and show the trend line. So insert chart, and we use scatter chart. We don't need the title because this is Weibull. For the series, we show the trend line. That's a polynomial to the 6th degree. For the equation, for the label, use the equation. For the legend, position at the bottom. We position the legend at the bottom. In the case of the EXPONDIST, we'll use the exponential. Likewise, in the Weibull at the probability density function, we also use the exponential. So it's our trend line. In the case of the cumulative distribution function, the saturation, we have the polynomial form. We'll calculate this polynomial regression coefficient using LOGEST, and the exponential coefficients using LINEST. The LOGEST and this one is the LINEST. We begin with the polynomial regression coefficient. So array formula of the x values raised to the power 0 to 6, and we enter LINEST for the cumulative distribution. So this would be LINEST data y, and data x. Likewise for the Weibull, so LINEST, data y, and data x. So here you have the polynomial regression coefficient of the cumulative distribution. Now we go to the decay or the probability density function. We use the logest, so logest data y, comma, data x, and this will also be logest data y, comma, data x. So we have 2.5, that is the 2.5 here, also the 2.5. We're missing the negative 2.5, so this is equal to ln of this value. Then this is also ln of this value. Of this value. So negative 2.5. So our exponential coefficients is negative 2.5 e to the negative 2.5x. So that is 2.5 times e to the negative 2.5x. So this is 2.5 times e to the negative 2.5x. And our polynomials, x to the 0, this is 0. 3.05 times 10 to the minus 32. This is 0. Coefficient of x, 2.05. So this is 2, rounded up as 2. Coefficient of x squared, negative 1.633. Negative 1.633. Coefficient of x cubed, 0.683. 0.683. Coefficient of x to the 4th, negative 0.154. Negative 0.154. Coefficient of x to the 5th, 0.0179, which is 1.79 times 10 to the minus 2, 0.0179. Coefficient of x to the 6th, negative 8.31 times 10 to the minus 4, negative 8.31 times 10 to the minus 4. Suppose we change our beta to 0.5. Their values are still the same, both in the exponential and the Weibull on the cumulative distribution function, and their values, that's 2 times e to the negative 2x. That's 2 times e to the negative 2x. Change this to 0.8. We have 1.25 times e to the negative 1.25x. Likewise in the EXPONDIST and the WEIBULList, 1.25 times e to the negative 1.25x. And the values here are also the same. Let's say our beta equals 1. So the values, the polynomials are the same in the cumulative distribution function. Likewise the probability density function, they're also 1 times e to the minus x. That's 1 times e to the minus x. Change this to 1.25. Now it's 0.8 times e to the minus 0.8x. And in the cumulative distribution function, they are still the same. Increase this to 2 and increase this to 2.5. So this completes the use of the Weibull and EXPONDIST, comparing EXPONDIST in the exponential distribution and the Weibull distribution function in Google Sheets.